Yaroslav, I can take some notes, make sure that the actions are covered and the detailed minutes are in EchoStool anyway.
Thank you, Hannes. Really appreciate that. Okay. Can we please close the doors at the back? There is quite a bit of noise going from there. Thank you. Thank you very much. Okay. Hello, everybody. Thank you for joining SEAT working group meeting. Again, make sure that you're in the right place. Before we begin, please do pay attention to the note well. I know that it's the second day, it's the fourth meeting of the second day. You might have seen that already, but again, this is important. We have all agreed to note well by signing into IETF, by joining this meeting, but please keep in mind that we are expected to behave in professional manner. I know that attestation for many of us is an exciting topic, and sometimes we cannot contain that excitement, but we still need to be respectful of each other and make sure that we criticize ideas and not people. If you know about intellectual property associated with things that are being presented here, make sure that you disclose that, and yeah, make sure that you follow all other items in the note well. With that, we have 5 main items on the agenda. So first, chairs will take a few minutes of your time. Then we will dive into pre, intra, and post-hand attestation comparison work that Usama has been doing. After that, Nathaniel is going to present his proposal for factor-based attestation and credentials transport scheme. After that, Tiro and Usama are going to walk us through the latest revision of remote attestation with exported authenticators, draft that has been around for a little while. And then finally, Yaron will take us through early attestation proposal. Any agenda bashing? Speak up now. Okay, Usama, anything you'd like to?
Yeah,
bash?
I would like to ask if it's would make sense to have the two intra handshake proposals together, maybe before or after. But I think that would be nice if they are both together. I mean, 3 and 5.
Sorry. It's a bit hard to hear you. Could you repeat that, please?
Oh, sorry. Okay. So I'm saying that maybe it would be better to have 3 and 5 together. That's what I meant. The intra handshake proposals together would probably be nice.
Okay.
I don't know what that means, Usama. Do you want us to change the order?
Yes, I was asking if 3 and 5 could be presented together. They are both intra, and it would be probably better to have them together, but it's fine if you think that's is just a suggestion.
All right. Unless there is strong desire to change the order, let's keep it as it is. Okay. Before we dive into other things, one point of order. Please do submit slides timely. I think the agenda was published a week before the meeting. Nancy and I sent requests for slides. We've asked presenters to submit their slides before the end of Sunday. Unfortunately, we have received some slides just an hour and a half before the meeting. The reason why slides are submitted upfront is so that chairs would be able to review them and ask to make some changes in some cases. So if you submit them late, then we don't have an opportunity to do that. We will be enforcing more strict submission timelines by the next meeting. So if you don't submit your slides timely, you risk to either present without slides or fall off the agenda. please do submit slides timely next time. Okay, so we have had interim a very lively discussion on two topics. One was use cases. So unfortunately, use cases draft was not updated in time for this meeting. So we today have 6 use cases that cover 9 different integration properties. As chairs, we believe that use cases should be eventually adopted and should be the foundation for any protocol definition work that we would be doing in this working group. So with that, let me start our first poll. Do you think if draft use cases draft ready for adoption? So please do answer yes if you've read it and you think it is ready for adoption, no if you read it and you think it's not, and no opinion if you haven't read the draft or otherwise you don't have opinion. This is not an adoption call. An adoption call we will be making on the mailing list, of course. This is just to get temperature in the room. Hank.
Yeah, hi, this is Hank. For me, it's the very first time ever that someone wants to adopt use cases as a document. Is this intended to be published as an RFC?
I don't believe so. Just
Okay.
to keep this more official as a
So it's more as a wiki, like okay,
Exactly.
that's fine. And then maybe we can transfer some the generic one into the main document or something. Then I'm fine. Okay.
Yeah.
Well, this was a clarifying question.
Thank you for the clarifying question, Hank. Okay, so we have 7 yes, 0 no, and 13 no opinions. So thank you very much for those who read the draft. Please do read the draft. We will be making a call for adoption on the mailing list soon. And of course, we need enough votes to adopt anything. The second interim topic was early attestation proposal. The proposal that describes how attestation can be performed within TLS handshake. So the initial proposal was clearly out of scope for of our charter, so we cannot adopt that. However, authors took the feedback and adjusted their proposals, and they now claim that the updated specification is within the charter. As a reminder, our charter claims that the attested protocol extension will not modify the protocol itself, may define extensions to support its goals, but will not modify, add, or remove any existing protocol messages or modify the key schedule. So we will have a presentation of this proposal. However, we would really like to know who, if anyone, other than authors, read this latest revision of the draft. Let me type in the poll. So the poll started. Please answer yes or no. If you don't remember, if you read it, you may answer no opinion, but better be precise. And I kindly ask authors not to vote. Okay, out of 53 attendees, according to Meet Echo, we have 7 who has read the draft. That's not a lot. Please do read the draft. It was published in good time before the meeting. Okay, and with that, again, as a reminder, our mailing list is sit@ietf.org. That is our main communication venue for anything that is related to the working group. All the adoption calls and all the other official business will be conducted via mailing list. So please do use that. And once something gets adopted, we will be following RFC 8874 and managing adopted documents on the GitHub. So there is nobody in the queue. And with that, let me transfer to Usama. To take us through his comparison of pre, intra, and post handshake attestation. Usama, is that the right slide deck?
Yes, that's correct.
Excellent. Let me pass the control to you.
Thank you.
Okay, go ahead.
Cool. Thanks very much. Welcome, everyone. I'm Usama, and together with Vyacheslav and Jan Perry, we have done some research in the past years, and which we kind of summarized in our draft intra versus post, with the motivation that starting from the use cases, it kind of sits in between the other drafts in the sense that it will kind of compare what are the different options, pre, intra, and post, presenting the taxonomy, and from that taxonomy doing the kind of the comparisons, which then we can see like which direction is most feasible and so on. So this is one specific part of that. So I requested 30-minute slot, then Nathaniel also came up with a proposal. So it's kind of not covering all of the space, and a specific one for security comparison, the research that we recently did. So with that, just as a quick reminder, we have attested TLS, and the whole protocol domain can overall be classified into 3 different classes. First one, pre-handshake attestation. The signing of the claims is from the remote attestation side, the most important thing, because it's the thing at which the cryptographically all the claims are set, and then they are protected. So if that happens before the TLS protocol has started, that's pre. If it is in between, that's intra. And if it's after, that's post handshake. So that's the kind of the taxonomy we have. People can think of other ways as well. I cryptographically and from my formal methods background, I find it the most feasible because this has direct meaning for what we will do in the property side. And that's why it's the temporal kind of the scale and not in what ways you do attestation. So independent of the methodology, this is dividing into 3 different schemes. Then there is a typical comparison. Just as a reminder, we made some changes to the one we had before, which is that there are 3 different layers at which we can compare protocol deployment and higher layer, meaning that whether the protocol changes in one of those, whether the deployment needs to change, or whether the higher layer, meaning some application layer or so on, needs to change. Tick represents that there is no change, cross represents that there is some change required. And in intra handshake, for example, in our assessment, it needs invasive changes to be secure. And in pre, it requires deployment changes. And all of those require basically higher layer changes, meaning that we are doing the comparison for the case of mutual attestation as well. So from the client side, basically, you always need to do some kind of verification, and that's typically at the higher layer. And also from pre-attestation side, so that's always the case that unless you restart the connection, basically, that's always post handshake. So with that little background, our AD instructed to exhaustively explore intra handshake attestation. And as I said, I will just focus on this specific part and kind of summarize the other results, what we have in the last slide. So what we did for that is we took the agentic AI case, a use case that was one of the use cases presented in a draft submitted to the SEAT working group. And in the bottom left side, you see agentic AI use case. From that, we derived the security goals. From the security goals, one of the most important one we define is the correlation property. How strongly the evidence is correlated with the underlying handshake. That's what the property defines, and we define 3 different levels that appears as the binding levels underneath that. And then there is a threat model, as always, for security analysis, and based on that threat model we do the formal analysis. On the right top you see different binding mechanisms and practical implementations. We took all the possible implementations that we could find and asked in different forums whatever was there, so we took all of that, and that we take as the formal model. I have on the left the left top, I have this layered attester and composite attester. So from attestation perspective, we can think of the layered attester and composite. So basically that covers all the trusted execution environments that we have, and that forms the system model. With now the properties and the model, we can do the formal analysis, and from the formal analysis with correlation properties, we find relay attacks, propose some mitigations, and then we go back in the loop to do it again and repeat that until we find a possible solution. So that's overall the approach, and I will not read all of that. So basically I have 2 categories. The first 4 are the base, let's say possible base binding mechanisms, and the rest 3 are the combinations of those. Attestation nonce you always need, that's why we take it always. So different combinations are possible, but we take the ones which are most relevant or makes the most sense. And one discussion point specifically that I have is that, is there any other useful binding mechanism or combination that folks think that should be considered other than the ones we have in the slide? And the second thing that I would like to discuss, and then I do the mapping over to different mechanisms like practical implementations. Metas AI, for example, follows 1, Draft Fusati TLS attestation version 6 follows 5, and Edgeless Systems Contrast, Cocos AI, Confidential Computing Consortium proof of concept use number 6. And that's another discussion point. If there is any other intra-handshake implementation known to somebody, that would be very useful for us to kind of analyze that as well, so we can have really exhaustive analysis over that. So I will probably pause here for a second to see if there are any opinions or any thoughts on this before proceeding.
So far,
on these 2 questions. Okay, so then I proceed. Then this is something that Eckert brought up at the charter time. There was a discussion that traffic secrets, handshake traffic secrets and application traffic secrets. So we define 3 different levels, and the first one is the GXY, that's the Diffie-Hellman shared secret. Second one is the handshake traffic secret of the client, and since we are dealing from the client side, and the third one is application traffic secret of the client. And the reasoning here is two-level or twofold, so to say, not level, sorry. The first one is the handshake traffic secret is basically used to encrypt those how to say, like the handshake messages, client hello, server, not client hello, sorry, encrypted extensions, certificate verify, and so on. These are the messages which are encrypted. And what I did is basically I removed all this encryption of these messages, and no security property changes. So that's why I write irrelevant for security goals. And on the other hand, if we have the application traffic secret, which is written at the bottom, that's a really useful thing, because the last step, which is shown as 3 with the secret that the client will send at the end of the protocol, if that is now unencrypted, that's basically becomes available to the adversary, and all the security is then lost, independent of whatever nice things we have done in the protocol. So that's really, really important to do, have some correlation to the application traffic secret rather than the handshake traffic secret. Second point that I want to raise here is, you see in the 3 steps on the right on authenticated key exchange, authentication, and application traffic. The second one is authentication, and for the intra handshake, basically The evidence is generated between step 3, the encrypted extensions and the certificate, so 1C and 2A. And in between that, the authentication process has not even started. That means basically server is not yet authenticated. So what we are attesting to is basically an unknown party, and that could itself be an attacker. That's the main issue here. So I show here two different types of the relay attacks that we have during this analysis. So I showed you 7 different mechanisms. This is the first of those mechanisms. And in this case, we had the TLS nonce used as the binding mechanism. So what an adversary in the middle can do is it can simply just relate over to a genuine attester. In this case, we have taken the AI agent. So that will generate an evidence, and with the right measurements, give it over back, and then it will show as its own evidence. And then the attested channel will be created between the verifying lying party and the adversary, rather than the verifying lying party and the genuine AI agent. Second attack is for mechanism number 4, which was for the public part of the key which the agent has. And it's possible by different means. For example, that key is accessible to some entity other than the AI agent, the genuine AI agent, I mean. For example, if it was provisioned at the runtime, it means it is accessible to at least somebody other than the AI agent itself. And also, for example, it can be leaked via vulnerability in the code. Even if the trusted execution environment is perfect, there are no vulnerabilities within the trusted execution environment. The code that we put into it, for example, like Heartbleed and so on, that can be problematic. So that can actually break the guarantee. This key can be leaked. And if this happens, then the adversary has the access to this key, and intra-handshake mechanisms actually then break out flat, because there is no other thing which can protect them from this kind of attacks. So what happens is basically the adversary has the private key. It can then form these messages, which are shown here: server hello, encrypted extension, certificate verify finished. And then the verifying lying party will basically accept it and send over finished, establish the connection, which is actually between the adversary, and the verifying lying party thinks it is connecting to a genuine AI agent. So the core problem that we see here is the binding evidence to unauthenticated peer. Thiru has some question. Go ahead, please.
Thanks, Osama, for the detailed analysis. If you could go back to the previous slide.
Yeah.
Right. I think you mean the identity private key that you're referring to, that's used in PKI, right? That's the one you're referring to getting leaked, or are you referring to the attestation key getting leaked?
No, it's not the attestation key. So that is in this case, this key is the one which is with the trusted execution environment. Okay. And for example, if you have the virtual machine, it will be within the virtual machine, not the one with the cloud provider.
So if my private key gets leaked, then anybody can mimic me, right? I mean, then all security is off the table, right?
Right, for these protocols specifically, but it's possible to protect it via post handshake, in which you can, even if this key is leaked and the session keys are not leaked, you can still have, because the exporter that the draft then we will present in there, that can still protect in that case.
Yeah, my question is, if an attacker gets access to my private keys, then all that they have to do is just, they can act as break my connection, send reset packets, and I'm forced to establish a new TLS session, and I could easily act as a man in the middle, right? I mean, all bets are off if private keys are lost. There is no protection, long-term protection, if private keys are lost, right?
I'm not sure what you are heading to, so that's what I'm also saying. So are you saying that it's impossible to protect, or what?
I'm saying none of the solutions can offer any protection if the long-term private keys are stolen, right?
It's not the long-term key. It's the key with the, so the scheme is the one which I presented in the last meeting. That is, the ephemeral key is the one which is with the VM, and the long-term key is the one which is from the cloud provider. That you have two roots of trust. If you lose one, the other one can still protect you. So that's the threat model that we have as presented in the last meeting. Does that clarify your question?
No, I'll let the others talk, but I probably will take it offline. Yeah, thanks.
Okay, sure. Thanks, June.
Could speak to microphone.
Okay. So I'm not an expert in the formal analysis, but I would like to know that, so how to guarantee that the code you write for the formal analysis itself is correct? So can we use the AI agent to write the formal analysis?
So I will not answer the part for the AI agent. I don't believe in AI agents to do formal analysis, but I can answer the first part, which is to say, I write my code, I submit to a conference. So this work that I'm presenting is being submitted in the ACNS conference, Applied Network Security Conference, which is one of
But
the...
still it's reviewed by a human, right?
It's
So
reviewed by
how we-
humans, sure. I mean,
Yeah, so how we guarantee
I
that
will,
the code is correct?
sure,
I mean, that's
sure, I got you.
the thing.
Okay, June, let me complete first. So I'm saying that, okay, so that's first level of defense, right? So they can actually check the code, and that's in good conferences, that's a requirement to check the code and so on. So it's just not accepting papers. Second thing is then I will make the code publicly available. All of you and are welcome to analyze that. If, for example, you are not an expert, we have experts in UFMRG, and actually, I think tomorrow or something like Thursday, I am actually presenting in the CFRG, which is the Crypto Forum Research Group. So we have all these experts there who have spent their lives doing with the crypto work, and we can get their feedback on it, right? So there are multiple levels. It's not just that somebody has done it. And if you're not an expert, of course, and if you trust in AI agents, you are welcome to run AI agents on the code that I will make it public. So that will be under Apache license 2.0. So I think you can just do anything that you want with that code. And
But
if you...
said is contrast to what you said. Can you go back some slides? You see that, okay, if some code is not written, where are you seeing this page? So there's a leakage because, okay, you see that you do not believe the code written by human, but then you see that you believe the formal analysis written by the human. So this is in contrast, right? So in one way, you see that, okay, the code is not well written. And in another way, you see that formal analysis is well written.
So there are two different things, June.
But they are
One
humans,
is
right?
talking about the code
Someone,
inside the
sorry,
TE.
just as a
Yeah.
reminder, we have 3 minutes remaining, so we may want to
Okay.
keep questions and answers concise.
Okay, I will leave the...
Sure. So maybe I just quickly pass through the slides and then come to you, Jonat. Is that fine for you?
Sure, yeah.
Thanks. Okay, so I think I have only a couple of those, so let me quickly go through them. The problem is finding evidence to unauthenticated peer, as in the slide, which was quite long. I showed that basically the server was not even authenticated at that point in time, when in intra-handshake, we bind the attestation evidence to that. So there is a need for implementation guidance, meaning that many implementations that we saw, including Meta's AI, and just as a reminder, Meta's AI was already reviewed by Trail of Bits, that one of the security assurance companies, or whatever you call it, right? The auditors of that. So they had already reviewed it, but we still found problems in that. So there are subtle problems that cannot be found without formal methods. So it provides quite a lot of value by doing formal analysis. So conveyance of attestation norms, different people were using like SNI or ALPN, which is not really meant for this specific purpose. And that's the need for implementation guidance and standardization is really there. And that's where we see the value in this work specifically. And CCC attestation, attested TLS proof of concept is a project at the CCC. There has been no update in that for last 3 years. And one question I have for discussion, which I will then surely you can send over the mailing list, was that if there is any other intra-handshake attestation implementation within the SEAT working group charter that we should consider. Finally, I think this is probably the last slide. So the relay attacks that we discovered in this work have already been acknowledged by Cocos AI, And they have like the one that I also sent to the seat mailing list. That's just a rephrase of all that what we have shared with you. And then finally, our summary is that pre-handshake attestation has replay and diversion attacks. That was the one of the first papers that we shared. And then intra-handshake diversion and relay attacks. Diversion was the Asia CCS paper, relay attack this paper. And to our knowledge, there is no currently known attacks on post-handshake attestation. And the last point I have already mentioned. So Yonat, please go ahead.
Ionut, please be brief.
Okay, thanks. So I'll try to be quick. So I just wanted to make one comment. So one of your slides
Should I
essentially
go down?
relies, yeah. So the slide essentially you say that if the attacker leaks the private part of the EK, then this this sort of binding is lost. And my point is, why do you think the attacker can or would stop at just the private part of EK? I mean, basically everything like master secret or application traffic secrets are all in the TE memory. So if the attacker can leak this part, then they can definitely leak the other things, which breaks any binding. So my point would be, either broaden the attack surface and just say everything can be leaked, or get rid of this attack avenue.
So I would, sure, I will very quickly answer this, Yonat. So there is, there could be a specific vulnerability in the code. It's not necessarily that the TE is broken, as I said. So one of the options I write here is leaked via vulnerability in code. The code within the TE, let's say, is broken. It doesn't necessarily mean that both will be leaked together. They are both independent, right? So even though they are stored together, the vulnerability might just leak the private key and not the other key.
Thank you, Sama. Let's move on to our next item on the agenda.
Thank you all.
Nathaniel, let me pass you the control. Okay, you should be able to control the sites now. Go ahead.
Okay. Thank you very much. So I have been a long-time lurker, first-time poster, first-time IETF. So I really appreciate the opportunity to present with such a healthy time slot for a 0-0 draft. Let's just there we go. So FAX is a hybrid intra-handshake remote attestation protocol with strong binding and per session freshness without modifying the TLS state machine. That was the design goal when I was working on this protocol over the past while, and it was motivated on the debate that was happening on the mailing list regarding affecting the TLS state machine with new messages, as well as changes to the key schedule. And I was approaching this not from the confidential computing side specifically, but still had the same threat model. I was approaching this from how do we access remote ephemeral VMs on really cheap $5 a month VMs, that sort of thing. And I've been using Proverif as a way to do QA, basically, to see, okay, I'm experimenting with this, what are the security properties? And then when Usama and colleagues started releasing their findings regarding relay attacks, diversion attacks, and released their open source model, I was able to take advantage of that and experiment with that some more. And when it came up to the opportunity to develop a draft and submit it just before the deadline. It's like, okay, we have early attestation, which in the 02 draft had a attestation message that was violating the state machine. And about an hour or two before I was ready to email the mailing group, 03 came out, threw away the attestation message, came up with a new cryptographic binder. And I'm like, oh, okay. I'm not exactly sure what to do now. So I have been working on Usama's model extensively, and I have no disagreement with any of the findings. What happens with the naive binding, with the old TLSA spec, does not provide strong binding and a comprehensive agreement on all the parameters. So even if you have the attestation signing key and the ephemeral key, and they are not compromised, everything's fine, you still don't get any of the security benefits, and that's proven in Usama's model. And I took that and I developed from there. So factor-based attestation is taking a unique approach besides adopting Usama's model. I have a private signing key, and I had devised a second authorization mechanism before I approached this with the secure enclaves and the T's. So that's why the architecture here is so strange, is because I was looking at this, okay, how do we secure, how do we have any assurance at all without just using a short-lived JOT to deploy services through Spiffy Spire or on cheap VMs, and then using Usama's model and the remote attestation and T's, I found that we were able to bring them together. When I ran the attestation binder from the early attestation 03, I found that it ended up having the exact same security properties that I had been working so hard on FACS. So that was an interesting finding, and I shared that with the mailing list. And I understand that Usama's had very many meetings. We'll continue engaging on the mailing list to see what my approach with his model is, where the challenges are. But what I found was that the security properties for both 03 and FACS met the security challenges, or surpassed the security challenges that the original identity crisis model had. So I take the long-term identity key, I take a key encapsulation mechanism. It doesn't have to be PQ, it can be ECDHE chems to encapsulate nonces and then bind them to evidence using an attestation key. So the threat model that I had developed is basically assuming that there was an active man in the middle the entire time. And that's where this encapsulated nonce system comes in. So there's a pre-authentication process where either the verifying client has an signed attestation result that already has a KEM for the public or for the server public KEM already available, or if there is an enrollment process, that's also how that can be found. But the presupposition is that the client already has access to the server's public KEM. Similar in concept to encrypted client hello, but that's focused purely on privacy and not on attestation. So the client encapsulates a challenge, a nonce. Only the recipient server has that. It takes that, unseals it, creates its own challenge nonce, encapsulates that to the public key for the client, sends that back, and the man in the middle is assumed in this case to have both the long-term signing key and the attestation key compromised. And going through the standard TLS state machine, you basically have a handshake and a handshake is what FACS effectively is without the attestation part. So adding attestation allows for additional, instead of just a single key compromise, which is what early attestation offers, where either the attestation key or the long-term key can either individually be compromised. FACS allows 2 out of 3 keys to be compromised and still maintain security. Here's the slide out of order. So pre-authentication has overlapping concepts in terms of being able to take a JOT or a CBOR, CWT, gather public commitments off of that, and then use that to encapsulate the nonces back and forth. And then at the end of that process, I have a proposal which I would have to approach the TLS working group about for EKU, where the encapsulated nonces can be derived into an ephemeral PSK and provide that third layer of protection. Now, if we take out this exotic encapsulation key process, it's effectively the same security properties as early attestation. In terms of key life cycles between the 3 drafts, I noted that effectively all of them have a very firm policy-based bound on key life cycles. There's no specific cryptographic way to be absolutely confident that a particular key is inside a T. And so that's the security posture that FACS has, is that it assumes that a number of keys can be compromised. Again, if we're working on systems that aren't attestation aware, there is going to be a much higher chance that keys can be compromised. And FACS essentially adds an additional layer with that KEM process. In either case, if you have a system, a T, with running an integer handshake with FACS, you have that additional assurance. If not, then you still have the resilience to single key compromise. Either you have the attestation key lost or the long-term key can be compromised, and you still have the security properties that you're expecting from attestated TLS. So there's 3 different binding choices that are currently on the table right now. Early attestation has that new binder that they've just proposed. That's the one that I ran directly in competition to the one that I had come up with on my own, that came up with the same security properties through Usama's proven model. And I found, okay, I should let the authors at early attestation know that their binder appears to meet the the requirements to mitigate the relay and diversion attacks as far as I've been able to see. And again, I'll need to interact with Usama and colleagues and other experts to make sure that the models that I've come up with are actually sound. But across all of them, and Usama also asked me on the mailing list to model his version as well. So all three of those are modeled. They're put up onto GitHub so that anyone can take a look at that, download it, run it, and provide feedback to see where the security properties actually are based off of security assumptions. So that's effectively it. Again, I've put together a Proverif playground with all three of the models that are currently proposed in the working group, just focused on the binder itself. Sure, Usama?
You can finish, it's fine. Are you
Sure.
done?
No, I'm almost done though. So those models are online, and I wasn't sure how long it would take to go through these slides. So there's a lot more in the draft that goes through mutual attestation, MTLS. I have gone through the other drafts to look at the different security properties. So one of the things that I noted from the expat draft was the ability to say, hey, a client is coming in trying to get the server to attest. Let's wait. Let's get the client to attest first during the intra handshake, and then have the server attest afterwards. All of that's in the draft. I haven't had a chance to put that into the slide, but there's a lot of detail in there, and I am interested, of course, in substantial review and collaborators on the facts draft, either from the existing authors or new collaborators. And I just wanted to, there's a bunch of names at the bottom there. They're all the different authors from the working group. Bruno Blanket is, of course, behind Proverif, and I have the work that I have put together and presented is based off of all of the work standing on the shoulders of the community. So I just wanted to acknowledge all of you. So go ahead, Osama.
Yeah, a huge thank you to you for doing all this work. I think this is very useful work, and we should really be doing this attestation. As the chairs also said, it's not an easy topic, and the formal methods, I believe, are the only way we can proceed forward. Yeah, and thanks also for doing the analysis for our draft, specifically for the expert draft. I really appreciate that. I didn't get the time, sorry for that, to check your models in detail, but I will definitely look into it. So that's, as an author, of course, I can be biased. That comes back to the June's question. So he was arguing that, okay, so you as a person write it, and I would like to know your thoughts on how do you as a developer, as well as, let's say, you are also an author, you are also doing the formal analysis of your own draft. How do you see being biased about it? Like, you could probably be biased. Of course, your models are available, we can check it. But yeah. I wonder, like, what opinion do you have on June's question? Thank you.
Sure. So because I'm operating by myself right now, certainly that's not the desired long-term goal here. But as I was looking into the problem space, examining the use cases of in terms of remote attestation outside of hardware roots of trust and all of that stuff. I was not extremely confident in my own ability to create sound protocol decisions. And so I came across Proverif incidentally during my research, and I've been using it actively as a QA kind of tool. So I'll come up with an idea, I'll do a bunch of research, I'll go through an implementation process. I'm like, okay, so at least the code works. Now let's go put that back into my Proverif model. And before you released your model to the open source, it was just my own handmade stuff, but I was double checking, oh, okay, this isn't going to work. Proverif found an attack. Now, because you have a model that is released with a published paper coming up, that gives me a lot more confidence. So I basically don't have any skepticism about the attacks. I do have skepticism about intra-handshake being completely unsecurable because it looks like my models say otherwise. But of course, we're going to have to go on list and talk back and forth to figure out exactly, where exactly the balance is here. But that's my position. That's how I've been working through this.
Yeah, thank you very much. I think the code that we will share for the relay attacks, that's not yet in the Asia CCS paper, that was in the ACNS paper. So we will hopefully release it very soon. So hopefully that would be helpful. Then I can look into your code, you can look into my code, and then we will reach some kind of agreement. Thanks very much for all the work.
And thank you for the opportunity to present. Thank you.
Thank you very much, Nathaniel. That is superb, especially given that it is your first presentation. So welcome, and thank you very much for your contribution to the SEED working group. Looking forward to seeing more of you on the list, more of your contributions and presentations at the following meetings. Thank you.
Appreciate that.
Okay, and now we move to our next presentation, which is exported authenticators. Tiru, Usama, which one of you will be driving the slides?
So I will do first, and then we will keep switching between. Sorry for that.
Okay,
so that
no worries. Just let me know if you want me to pass over the control to Tiru.
Okay, sure. Thanks. So yeah, hi again. This is our expert draft, the first draft of the SEED working group. Sorry. We are a team of Thomas, Tiru, Yaron, Hannes, and Jonat. And I and Tiru will present some parts of the draft, what we have done since IETF 1 to 4. So I'm going to describe about the community interest since IETF 1 to 4. So we have 4 different companies, GFO, GH, Elixir Europe. Pavel is doing the development there. Agilist Marcus is doing the development, Zama, Ayub, and Flashport Spec Jones. So we have 4 different developments that will come out, and hopefully we will have a lot of opportunity of improving the specifications and seeing where the problems are and seeing what the best way is for the development to proceed. Cocos AI, as I mentioned in the previous talk, they have acknowledged the attacks. They have published their plan to move towards post-handshake. And then there are 4 internet drafts, which are using our protocol already. 3 of them have it published, and the 4th one is in the editor's version. I have the link down there. And other than that, there is another draft which has made a public commitment. I have put the commitment link in there. This work was cited in the CCC response to NIST request for information on AI agents, and it was the only attested TLS protocol which was cited in there. Other than that, I had an invited talk from Global Platform where they were interested in the attested TLS topic and attestation in general. We presented our draft there, And finally, in several of other meetings of the CCC attestation SIG, which we by charter are required to coordinate with, and other forums, reputable forums like FOSDEM, Linux Plumbers Conference, and GA4GH. It has been presented several times. And now I would request the chairs to pass the control over to Thiru, please.
Thanks, Osama, for the start. Can you hear me?
Loud and clear. Go ahead.
Wonderful. Thanks. Yeah, so this document pretty much relies on RFC 9261. It extends RFC 9261 by adding new extensions. A quick recap on RFC 9261 is it's basically a post handshake authentication mechanism. It basically uses authenticator request and authenticator to send certificate request and to get the entire certificate verify and finished. It's relying on the TLS exporter to basically derive the handshake context and as well as to derive the HMAC key for the finished messages. So pretty much this draft is extending RFC 9261 to convey the evidence or attestation results. So to meet the charter of the seat, right? I mean, even without meeting the charter of the seat from day one, we have been, since this draft has been, even before the working group was created, we have been doing changes to the to this document just to make it post handshake. So the intent was never to modify any of the TLS handshake protocols. And if you look into this example, the client is basically asking the server to provide attestation evidence or results. So it would basically send an authenticator request and the server would provide the evidence back in the certificate message with the new extension defined in the document. So one difference that I think Osama has highlighted in the previous deck is that by the time this attestation is exchanged, the client and server authentication would have completed as part of the TLS handshake. And this is an additional exchange that would happen to do the attestation in addition to basically re-authenticating the server as well, because we are piggybacking on the certificate messages. Some of the key benefits that we see from this document is it's a simple, clean solution. It requires minimal changes to TLS and to integrate remote attestation. Osama and team have been doing the formal analysis, and so far he has not identified any threats that would ask us to change this document. We're just adding new TLS extensions, as I previously said, and we don't modify the key schedule. PRATS currently supports two models. One is the background check and passport model. Both the models are supported in this document. And the most important functionality that that interests me is basically the reattestation part, especially for long-lived sessions. For instance, in 3GPP networks, we have most of the sessions are quite long-lived, and we would like to see a reattestation done periodically.
Thiru, we have a question from Jonathan. Would you like to take it now?
Sure.
Jonathan, go ahead.
Hi. So I did the formal analysis of exported authenticators way back when. I think that was 2015, 2016, something like that. There's definitely, I don't know if you read that paper, but if you send multiple exported authenticators on the same TLS channel, they are not bound to each other. They are only bound to the underlying session.
Right. And what is the threat vector with that? Sorry, I didn't get that.
So like if you imagine, I mean, with attestation, it's not as obvious. But if you imagine you had the TLS terminator sharing, like sending communications to a backend, right? Mm-hmm. Then you don't have any guarantee that the two backends are the same backend. You just have the TLS connection is connecting to backend 1 and to backend 2. You don't know the backend 1 is backend 2.
in case if the secrets are shared by the two backends?
No, the secrets are shared by the TLS server. So if the TLS, an exporter to authenticator tells you that the TLS server shares state with backend 1, and it tells you that the TLS server shares state with backend 2. It doesn't say backend 1 and backend 2 share state with each other.
Okay.
So it's not obvious that supports reattestation. I don't see how that is obvious.
Yeah, so when we designed this, we were assuming that there's a TLS server. We were not assuming that the TLS server was sharing state with backend services, basically, right? And since we are relying on the exporter material, TLS exporter material, we thought it's only purview to the client and the server and not to anyone else. But if the server is leaking that to backend services, then that threat model needs to be discussed further.
Well, so if you think of a CDN use case, right? The CDN would use the exported authenticator to say, I control example.com and I control jslibrary.com, right? It's not saying that they're leaking the secrets. It's just saying, I control both these domains and I can serve content from both of them. But it doesn't mean that they're owned by the same person. It just means I'm a CDN for both of them.
Right. And in this case, obviously, I think the attestation would be different because these services would be running on different platforms. Right. I think that's a use case that we have not at least discussed in the use case document. So that's definitely requires some more discussion. Thanks for bringing it up. But for the sake of this document, we were assuming it's the same identity that was authenticated both pre and post handshake. So we did not. I know exported authenticators was written with multiple identities in mind. So, but for this model, for the use cases that at least were written in the use cases document, it's always the same identity that's used in the pre and post handshake.
Just as a reminder, we have 10 minutes remaining, so you may want to
I'll speed up. Right. Where were we? Yeah. So it supports full claim availability because the authentication has already succeeded. And so far as the use cases that we have been developing, it meets most of the use cases other than the ones which pretty much want to do it before the handshake. But I think it meets majority of the use cases that were discussed in the use cases document. Next slide. Sorry. Yeah. This is one example that the client basically sends an authenticator request. It includes the nonce that it gets from the verifier, and the server uses this nonce, provides it the key, gets the evidence, and sends the evidence back in the certificate message. The client takes that evidence, either self-validates it or takes it back to the verifier to validate it, and then decides whether to progress the TLS connection or break it. Thanks. Osama, you can go next.
Right. Thank you, Thiru. So yeah, I will guide you through now the formal analysis that I'm doing and the status where we are. And specifically, hopefully it will also answer Jonathan's question because, for example, in 2B, you will see one key, brief EK, and in 3C, you will see another key, which is brief LTK. So we have two different keys. And in the main handshake, it's providing proof of possession of the first one. In the post handshake part, which is the 3C certificate verifier, it's providing the proof of possession of the second one. And on that specific point that Jonathan was mentioning, that we have two exported authenticators linked to the original connection, but not linked to each other. So that part is solved via the measurements, which are continual and which keep like the TPM keeps the measurements of at the runtime that whatever code is loaded, so it's keeping that state. So that state is measured independent of these keys. So I believe that should solve the problem, but if not, please feel free to explain further. Nathaniel, I will take the questions at the end. Let me try to go through some of the stuff that we have. I think we are lagging behind in time. Sorry for that. So what I want to say here is 1 and 2 are pretty much standard TLS, and we have some steps on top of that, which are in part 3, and they look like very much like the TLS, which is that certificate verify finished, exactly the same as the ones in the handshake, and client certificate request, which is exactly the same as the certificate request, which is in the original TLS, but in the other way direction. In original, it's server to client. Here, it's client to server. So about the authenticator request, we have an A, which let's say it represents the attestation nonce. So the certificate request context for that specific message, let's say we take it as the attestation nonce. And then secondly, we had the authenticator, which the server or the attester will send back to the client. And the key point here, because I'm running out of time, I will show you or tell you the main idea behind this is that in each of those, like equation number 2, 4, and 6, you see the exporters, which means that all of these 3 messages are linked back to the original TLS connection, which was established. And that's why there is a binding for each of those messages. It's not possible to replace them or to get it from somewhere else and so on. And there is also in 2, 4, and 6, you see attestation nonce, which means that it will be really fresh for each time it's derived. L is the length of the key that you want to derive. And there are labels like attestation RD, HC, and FK to distinguish the 3 from each other so that they are not mixed and matched because all other things, NA and L, other parameters are the same. So with that, for equation number 3, I will give you just a quick idea, which is that the evidence is generated with this R data, which contains the public key of the server, as well as the exporter, which we derived above. And that means basically it's bound to the channel as well as to the server's identity. In equation number 5, you will see that it's like the running hash transcript in the original TLS protocol. And in addition to the exporter, it has the message which was before this, which is the certificate. CRC was, I think, what was CRC? I have to recall. CRC was certificate request. Yeah, client certificate request. So what it's doing is basically exporters are derived at this point in time. It means it takes exporters appended with this, and sends it over as part of this one. So it's taking, other than client finished, all the messages which are here and then taking a hash over it. And similarly, in this 81, we had all the messages up to certificate. Only message left over for finished is certificate verify. It takes that, and that's why it has all the messages. So continuing just like TLS, it is a TLS handshake protocol. It has the running hash transcript so that if one of the messages is, let's say, modified and so on, the other endpoint, can actually then detect that. The core idea for relay attack protection is exactly what I mentioned, that the 3 of the messages which I showed on last slide, all of them had exporters, and all of them had the transcript hash, and that's why it's strongly bound to the connection. And evidence is bound to a fully authenticated endpoint, meaning that the time exporter was generated, server finished message, server was fully authenticated. There is nothing left behind. And how we model it is like correlation properties. I have presented these correlation properties in UFMRG in the last meeting. So if you are interested, please have a look at that video. And finally, I have some discussion points, which are, we would like to request a working group adoption call, because we think that we are at a good stage with this draft. We have good interest from the community on this, and we believe that we are converging on the direction forward, and we would like to have that adoption call to proceed together with the working group rather than just the authors. So I will, as I already mentioned, I will present it at CFRG for crypto scrutiny that I presented here in more detail so that they can also give their feedback. Nick kindly provided some pointers to the formal analysis and some other things which are related to RFC 9261, which were kind of blocking us from progress. So that's resolved. And thanks to him, we will look into these readings and do the rest of the work which is required for this. And some of that requires filing an errata for RFC 9261 that I will work with Nick for doing that. And for this specific draft, we have some open issues. We would welcome any feedback on that. And one specific issue which is open is like shim layer versus per protocol integration. I think it's issue number 56. So in the CCC attestation SIG, people were converging towards shim layer, but we would like to hear from other implementers as well and seek more guidance. That's pretty much it. There are links that you can have a look at. Thanks very much. Jonathan, please go ahead.
Hi. So I just had another thought. The nonce that we didn't use the certificate request context as a nonce, or we didn't model it as a nonce, and you actually would only, if you use it as a nonce, you only get freshness for one side. So the server, I think it was in your diagram, you could send them the same certificate request multiple times and they wouldn't notice because you only get a nonce in one direction.
Wait, just to be on the same page. Just to be on the same page, so the figure I'm showing here is the server as the attester. So there is only one party being attested. And you could have also the other party being attested, meaning mutual attestation. In that case, there will be similar message like the authenticator request going from the server to the client. And that will contain the nonce from the server side to the client side. So the kind of thing that I am showing here, authenticator request would be then the same for the other one. Does that make sense, or did I get it wrong?
Yeah, I mean, it makes, I can't see an obvious attack, but just like we never modeled that as a nonce, and so it's not obvious to me that would give you freshness.
Unfortunately, we are out of time.
Yeah.
We need to move on to our final presentation of the day. Just one point I'd like to make, Usama, in terms of adoption call. First, we need to adopt use cases and then judge any specific proposals against those use cases. Yaron, over to you.
Thank you, Yaroslav. Can you actually hear me?
Loud and clear. Go ahead.
Thank you. Okay, so I'll be discussing the early attestation draft. We have made very significant progress since the last discussion of this draft. We got a very strong message that some people at least like the approach, but that we are clearly not within the CET charter and we'd better do something about it. So we did. The new attestation message was replaced by an extension to the certificate message, also called attestation, and the binder was rewritten, so now it is wholly decoupled from the TLS key schedule, so there's no reason to suggest that we are changing the key schedule. We believe that this brings us completely within the definitions of the charter. In addition to these two major changes, we looked at some of the design options for attestation, and I'll go into details later. And in particular, the internal architecture between the TLS stack and the T.
Yaron, sorry, your voice is really choppy now. Maybe you want to stop your video and save some bandwidth.
Sure, let me do that.
Okay, now it's
Thank
better.
you.
And also, do you want to take questions now, or or go through the slides first?
Let me at least complete the slide. So we have a discussion diagram on how the TLS stack and the T interoperate and what that means for some of the final points of security of the protocol. And lastly, and this is not on the slide, I'd like to thank Nathaniel for basically working with ProVerif to prove that our binder design is sound and does in fact fulfill the security properties. Yes, Osama.
Right. So I have a bit of a concern on when you say that it's within the seat charter. The reason is that basically you are using the key derivation functions, right? And it doesn't matter whether you use it for a nonce or wherever you use it. I believe that if you are using these key derivation functions, they are basically key part of the key schedule. And I don't fully understand why that is the case, that you claim that it is within the seat charter while it says that we will not modify the key schedule itself. Can you explain that, please?
Thank you for your question. I think key derivation functions are a primitive, just like SHA-256. I don't think anybody has a monopoly on key derivation functions or any other primitive. Nathaniel?
Sure, but I have a follow-up on this. So
Yes.
I don't believe that, for example, like if you
Sorry, Usama, Yaron, you have 14 minutes, so it's up to you if you want to take questions now or if you want to go through your presentation first.
Okay, so let me move on. Semantically, there is no change. We are still using a CMW, conceptual message wrapper, that's wrapping RAT's evidence or attestation results. Now it's an extension to the certificate entry, so it lives inside the certificate message and only apply and may only apply to the identity certificate. The binder is probably the more interesting part. This is now separate from the key schedule, and it binds the attestation to the specific TLS handshake through the transcript, as well as the PKI identity, so the identity key of the attester. The inputs are a message transcript that's modeled on the handshake context, and the public key. And this binder is now used as a nonce when the TE signs the evidence or the attestation results. And the complete derivation is shown on the screen. In my mind, the more interesting part is the architectural considerations. We basically identified the exact point where TLS notions and terminology need to be converted into TE notions and vice versa. So there's a layer in between that talks TLS or an opaque CMW to the TLS stack and talks nonce and signed evidence or attestation results downwards to the TE, And now the question becomes, where is that adaptation layer implemented? We claim that it has to be measured in any case. And for full security, we would rather have the adaptation layer as part of the TE API interface. There are additional questions related to the definition of conceptual messages in RATS, where those have been defined to ensure that components that are not aware of the details of the TEE actually do not need to deal with implementation details. So the conceptual message needs to be transferred to the verifier rather than the TLS stack diving into the bit level details to verify it. So there's discussion about that and how this can be made to work. It's not all resolved yet, but we believe we have a way forward that retains the architectural integrity. Reattestation in draft 02, we were very opinionated on reattestation. We went back on that one. We do agree that reattestation is an important part, and we are presenting three options. One is what we had in 02, which is extended key update. However, extended key update is still being discussed, still being modified in the TLS working group, so we're not sure where this is heading. Option B is, if you want reattestation, just redo the TLS connection. Not very beautiful,
Yaron,
but
your voice,
yeah.
Yaron, your voice is choppy again. It sounds like you have some microphone wiring issues. Not sure if you can do something about it.
Yeah, it's not wired, and I guess it's my internet. So what I can do is apologize. Is it too bad to actually hear?
Now you're back. So go ahead.
Okay, thank you, and apologies. And the third option is post-handshake with a certificate update. In any case, all three options are presented, and the working group will need to make a call on that. And lastly, for client-side attestation, which is not necessarily the mainstream use case, actually, we could use standard post-handshake client authentication straight from TLS. So there's an open pull request about that one. It's not yet in the draft. As next steps, we believe the draft is now fully within the charter and is in fact both nearly complete and implementable. And we would like to request the working group to adopt it formally. And I will take questions. Osama?
Yeah, thank you. So going back to the discussion on the, oh, here you go. So on the key schedule, for example, I give you one specific example. Like there is early secret, and the inputs for that specifically are both 0 and 0. So that's there is nothing coming from the key schedule into it. That's the starting point where it starts. and we still call it early secret because it's using these KDF functions and all that nice things. So I wonder why you don't consider that these functions so as the part of the key schedule itself. So I would like a bit
This
more
is
clarity on that.
this is totally on terminology, and in fact, we do call out explicitly in the draft that even though it's called secret, it is not a secret. So I'm not sure of the point you're making. No, this is
I,
not making
I,
any changes to the TLS key schedule.
So, I mean, I'm giving you a counterexample to what you were saying. I'm saying that early secret is derived via two inputs, both of them are zero, and we still call that secret, right? So it's, or forget about the secret. So, of course, like with constant inputs, it's not a secret. So maybe secret is the word which is confusing. Early secret is a key in the key schedule, right? So do you agree with that or not? It's in the, if you see section 7.1 of the key schedule 8446 bis, it's the first key in the tree that's shown in that figure, whatever that figure is. And that both of these inputs to that key schedule inputs are both constant. The result is also a constant, but we call that a key in the key schedule because it's derived from the key derivation functions, which are the HKDF functions.
I
And
think we have a disagreement on what constitutes a change to the key schedule, and let's leave it at that. There are two more people in the line, and only 4 minutes remaining. June.
So can you go back to the page 5?
I'll try. This
Yes.
one.
So yes. So I have a question about the nouns, because you see that there's nouns goes down, but there's no nouns goes up. That means that you have a cache of the nouns in the early attestation adaptive layer, or you include it in the signed evidence.
We include, so yes, we include it in the signed evidence. It's a nonce that's used while signing the evidence / attestation results.
So in that case, you do not need to include the nouns in the CMW nouns because it's already inside the signed evidence.
You're probably right. You're probably right. Yes.
Okay, thank you.
Nathaniel?
Hi, I just wanted to clarify that, yes, I did do the formal modeling. I am not an academic, and so I have released the models to the public for public review. It's not exactly orthodox with formal modeling, but that's the disclaimer. But in terms of phrasing and wording, considering the hang up on the use of the word derived secret, a proposal change to the draft is just to use just cryptographic primitives that aren't being called from the TLS thing. It's still a public commitment. It's not a secret. So a change of phrasing would have the exact same security properties. So maybe that's a way to approach it.
Yeah, we're just being very conservative
Yeah.
on what primitives we're using, but let's have that discussion offline. You may be right, it may be a good solution.
Great. Thank you very much, Sharon, for your presentation, and thank you very much for staying on time or ahead of time. So thanks all the presenters who presented today. One thing that I would like to highlight is use cases, really what should be defining the solution that we will be adopting and developing within the working group, not formal analysis. Formal analysis is something that we would like to optionally see happening later. So use cases would be defining security properties of the solution that we will be developing, not other way around. It's not security properties define the use cases. So I kindly ask everyone to please take a look at the use cases draft. see if you're happy with the use cases. Is there something that you strongly believe should be added or modified in the document? And then we will be taking a working group further once use cases have been adopted. So Nancy, anything from your side?
Nope. I appreciate you running all the meeting while you're there.
My pleasure. Thank you. And thank you very much for remote participants for being with us, regardless of faraway time zones where you might be. Thanks again, and have a good rest of your morning, day, evening, night. Thank you.